Hello, here we are together at the last part of the physical layer, part 3. The topics that will be discussed at this session will be fiber optic cabling and wireless media. The fiber optic cabling is the other type of cabling used in network, but since it is expensive, it's not commonly used at the various types of copper cabling. But fiber optic cabling has certain properties that make it the best option in certain situations. The optical fiber cable transmits data over longer distances and at a higher bandwidth than any other networking media. Unlike copper wires, fiber optic cable can transmit signals with less attenuation and is completely immune to the electromagnetic interference and radio frequency interference. Optical fiber is commonly used to interconnect network devices. The optical fiber is a flexible but extremely thin transparent strand of very pure glass, not much bigger than a human hair. Bits are encoded on the fiber as light impulses, and the fiber optic cable acts as a waveguide or light pipe to transmit light between two ends with minimal loss of signal. Fiber optic cables are broadly classified in two types. The first one is a single-mode fiber that consists of a very small core and uses expensive laser technology to send a signal ray of light, as it is shown in the figure. The single-mode fiber is popular in long-distance situations spanning hundreds of kilometers, such as those required in long-haul telephony and cable TV applications. And the second type is the multi-mode fiber, where it consists of a larger core and uses LED emitters to send light pulses. Specifically, light from a LED enters the multi-mode fiber at different angles, as it is shown in the figure. The multi-mode fibers are very popular in LAN because they can be powered by low-cost LEDs. Each provides bandwidth up to 10 gigabits over link length of up to 550 meters. One of the highlighted differences between the multi-mode fiber and single-mode fiber is the amount of dispersion. Dispersion refers to the spreading out of a light pulse over time. Increased dispersion means increased loss of signal strength. Multi-mode fiber has a greater dispersion than single-mode fiber. That is why multi-mode fiber can only travel up to 500 meters before the signal loss. The fiber optic cabling is now being used in 4 types of industry. Enterprise networks, where they are used for backbone cabling application and interconnecting infrastructure devices. For fiber to the home industry, used to provide always-on broadband services to homes and small businesses. Long-haul networks, where it is used by service provider to connect countries and cities. And lastly, at the submarine cable networks, where it is used to provide reliable high-speed, high-capacity solution capable of surviving in harsh undersea environment at up to transoceanic distances. Search the internet for submarine cable technology map, and what you will see, it will be the view various map online. And you will be surprised with what you will see there. An optical fiber connector terminates the end of an optical fiber. A variety of optical fiber connectors are available. The main differences among the type of connectors are dimension and the method of coupling. Businesses decide on the type of connectors that will be used based on their equipment. So the first one is the straight tip connectors and is a connectors that are one of the first one to be used, and they lock securely with a twist on or twist off bayonet style mechanism. The second one is the subscriber connectors, and are sometimes referred to as square connectors or standard connectors. They are widely adopted at LAN and WAN connector that use a push-pull mechanism to ensure positive insertion. These connectors type is used with multi-mode and single-mode fiber. The third one is lucent connectors, simplex connectors, and are small version of the subscriber connectors. They are sometimes called little or local connectors and are quickly growing in the popularity due to their smaller size. The last one is the duplex multimode connector, and they are similar to the lucent connectors but use a duplex connectors. Because until recently, light could only travel in one direction over optical fiber. The two fibers were required to support the full duplex operation. Therefore, the fiber optic patch cables bundled together two optical fiber cables and terminate them with a pair of standard single fiber connectors. Some fiber connectors accept both the transmitting and receiving fibers in a single connector known as duplex connectors, as it is shown in the figure. The fiber patch cords are required for interconnecting infrastructure devices. These use the color distinguishes between single-mode and multi-mode patch cords. A yellow jacket is for single-mode fiber cables and orange or aqua for multi-mode fiber cables. And depending on that, we have the subscriber connector multi-mode patch cord. We have the lucent connector single mode patch cord. We also have the straight tip lucent connectors multi-mode patch cord. And lastly, we have the subscriber connector and straight tip single mode patch cord. There are many advantages by using fiber optic cable compared to copper cable. The table highlights some of the three differences between them. At the present, in most enterprise environments, optical fiber is primarily used as a backbone cabling for high traffic, point-to-point connections between data distribution facilities. It is also used for the interconnection of buildings in multi-building campuses. Because fiber optic cables do not conduct electricity and have a low signal loss, they are very well suited for those uses. Wireless media carry electromagnetic signals that represent the binary digit of data communication using radio or microwave frequencies. Wireless media provide the greatest mobility options for all media, and the number of wireless-enabled devices continue to increase. Wireless is now the primary way users connect to home and enterprise networks. There are some of the limitations of wireless. The first one is the coverage area. Wireless data communication technologies work well in open environments. However, certain construction material used in buildings and structures and the local terrain will limit the effective coverage. Interface is the second one. Wireless is susceptible to interference and can be disrupted by such common devices as household cordless phones, some types of fluorescent lights, microwave ovens, and other wireless communications. The third one is security. Wireless communication coverage requires no access to a physical stand or media. Therefore, devices and users not authorized for access to the network can gain access to the transmission. Network security is a major component of wireless network administration. The last one is the shared medium. Wireless LAN operate in half duplex, which means only one device can send or receive at a time. The wireless medium is shared amongst all wireless users. Many users accessing the wireless LAN simultaneously result in reduced bandwidth for each user. Although wireless is increasing in popularity for desktop connectivity, copper and fiber are the most popular physical layer media for deployment of intermediary network devices such as routers and switches. Physical layer specifications are applied to areas that include data to radio signal encoding, frequency and power of transmission, signal reception and decoding requirements, antenna design and construction. And therefore, there are three wireless standards. There is the first one, the Wi-Fi, where wireless LAN technology, commonly referred to as Wi-Fi, and wireless LAN use a connection-based protocol known as carrier-sense multiple access collision avoidance. The wireless network interface card must first listen before transmitting to determine if the radio channel is clear. If another wireless device is transmitting, then the network interface card must wait until the channel is clear. Wi-Fi is trademark of the Wi-Fi Alliance. Wi-Fi is used with certified wireless LAN devices based on the known standards. We have even Bluetooth. This is a wireless personal area network called wireless PAN standard, commonly known as Bluetooth. It uses a device pairing process to communicate over distance from 1 to 100 meters. We have even the WiMAX, commonly known as Worldwide Interoperability for Microwave Access. This wireless standard uses a point-to-multipoint technology to provide wireless broadband access. And lastly, we have even ZigBee. ZigBee is specification used for low data rate, low power communication. It is intended for applications that require short range, low data rates, and long battery life. ZigBee is typically used for industrial and Internet of Things environments such as wireless light switches and medical device data collection. A common wireless data implementation is enabling devices to connect wirelessly via a LAN. A wireless LAN requires the following network devices. It requires a wireless access point, and this concentrates the wireless signal from user and connect the existing copper-based network infrastructure such as Ethernet. Home and small business wireless routers integrate the function of a router, switch, and access point into one device. And secondly, they must have even wireless network interface adapters. These provide wireless communication capability to network hosts. As the technology has developed, a number of wireless LAN Ethernet-based standards have emerged. When purchasing wireless device, ensure compatibility and interoperability. The benefits of wireless data communication technologies are evident, especially the saving on costly premises wiring and the convenience of host mobility. Network administrator must develop and apply stringent security policies and process to protect wireless LAN from unauthorized access and damage. And with the end of the third session of the physical layer, we are ending all the topics about this layer. See you in the next session, and don't forget to subscribe at AA Networking for new videos coming up, and see you soon.